Okay, let's continue. So just recap before the break. So before the break, we learned how to establish or write the Levi structures for ion, right? So there's additional steps in step number 2 when you count the total electron. If it's a negative charge, you remove numbers of electron based on the negative charge. Same for the positive. Now, for example, this one. So this one will go very quick. See if you're able to understand. So if the question asks you to write the Levi structures for NH4 positive. So first steps also refer to periodic table. Nitrogen is group number 5, right? H is group number 1. So 5 plus 4 electron from the H4. So 5 plus 4 is 9. But this is positive charge. So positive charge we remove or add. We remove, we throw away electron. So 9, 5 plus, okay, 9 minus 1 is 8. Okay. Then you group them together. At the end, you remember to use the bracket for the Levi structures. That's all. So this is just so this one you go home and see. If you have question, you can come back and ask me, right? It's just a check lah. Okay. So for example, this one, I give you the wrong answer. For example, in this example, I purposely put the positive charge in the question, in the provided answer on the slides. But this is the wrong answer because it's a positive charge, so it should not be plus, but it should be removed. Okay. Okay. So this is the example things that will be come up from your for your assignment later. So don't blindly copy the answer. Yeah. Okay, so this is the final answer. If you have a question, you can come to find me during the consultation hour. At the end, we expect you to give me this kind of answer. H double dot bracket plus, or change the dot to the line. Okay, to the line. Right. Remember the bracket and the positive charge or negative charge, yeah? Okay. Okay, so this one, I will also let you to view at your free time or your revision time. Same procedure for ClO negative ion. So just to remember, if you see negative ion, remember to put the bracket and the positive or negative charge on the right hand corner. That is the thing. Steps still the same, the 4 steps. Repeat the 4 steps. Yeah. So this one you can check this one. All right. Now we go to after the break, we go to another skill where you will predict the model. So when you predict the rules, sometimes there are some exception exist, means there are some special combination that octet rule do not apply, or in the real scenario you will find this combination exists, although in the theory part when you calculate it do not achieve octet rules. But when you go to experiment or in the real life, when you go and check the bonding using instrument, you won't see octet rules. For example, NO. NO, you got 11 electron. You should able to understand if you see electron 11. N is 5, oxygen is 5, N is 5, O is 6. So it's 11. So the best you can do is something like this. Right? So N, 5, O, 6, and then you have double bond. Okay. So nitrogen, they do not have octet. So this is not a great Levi structures. It's just an extreme case. Okay. Extreme case do not exist, do not come out in your test, just for info. I don't ask you extreme case. Okay, but just info, NO do exist in nature. This kind of combination do exist. They exist but not stable. You will try to grab somebody else, combine with other element to form stable compound. This is during the process, like you mix here and there, and then this one suddenly come out from the products. Then it will join with other element. Okay. Okay. This one you read now. So it is impossible to write good Levi structure for molecule that have odd numbers. Odd and even numbers, you know the difference, right? So you have an odd number, so it's impossible. You cannot balance the things, right? So in such case, we write the best Levi structures the best we can. So this is just the notes. If you for the real life application, sometimes when you go to work, you try to balance it, you cannot, and you check in the instrument actually exists, so you give the best lah. Okay, another just now is NO, another one is boron lah. This just for info lah. Just for info. Boron, they have 6. So boron F3, boron H3. So in nature, if you build the Levi structure, it's not balanced. You do not apply the octet rules. Okay. Third exception also common with this SF6 and PCl, phosphoric, right? So sometimes it can be more than 8 electrons. It can be more. So sometimes this is exception. Okay. So of course the exception already told you in the class. Sometimes, for example, in tutorial or in your assignment, I will ask you something about this one. Then you need to draw lah. But in common test, I won't ask you this extreme case. Right. Okay. So this one, in some textbook, you'll see words like expanded octet and so on. This one, when you do your master's or PhD, then you'll come to this one, right? Okay, next we look at resonance. The word resonance means you have more than one structures. So in the first class, we have some games with the fruits, right? So sometimes the orientation, when you rotate, it looks similar. So they are called resonance. They're called resonance. So for example, SO2, right? Sulfur oxide. SO2. Okay. So sometimes I'll ask you to give definition, right? Give definition of resonance structure. So you need to write this one. So resonance structures are structures that have more than one good Levi structures. All right. Now, resonance structure, you start with the previous steps, the 4 steps, similar, same. First step, you write the skeletal structure. So S, group number, periodic table, group number. Six. So oxygen also 6, right? So skeletal structures, rules of thumb, if you see individual element, usually in the middle. So when you write the skeletal structure, S in the middle, O at the side. Second one, total number of electron. So 6 multiply 3, you got 18. Right? Sulfur 6, you write the equation. Total of valence electron equal number electron in sulfur plus number electron in oxygen, like what you did in the previous session. Okay. So again, this is just a reminder. Always draw the element dot Levi structure for the element, so that when you do calculation later, you can double check your answer, right? Okay, so again, this is just a highlight. Do not confuse this equation with the ions. Ion have one more additional steps with take away or plus electron. Yeah, so this one just the highlight for your revision later. Okay. So answer is 18, and then what is important is what is resonance structures. So when you group, right, step number 3, apply octet rules or duet rules, and then give bonding. All right, double bond or triple bond. So you distribute in the middle, sulfur, you got 4 in the middle, although it's 6, right? So sulfur, you do the pair first, right? 2 left, 2 right. So there's one more, right? Okay, 2, then you use 4. 18 minus 4, you have 16. Sorry, 14. 14 divided by oxygen, 2 oxygen. So you got 7, right? So you need to build the structures. Is it correct? But you have 18, right? You build the lone pair for the oxygen. So this is the bonding pair. You build the bonding pair, then you go for the lone pair. Then you have another 2. Right? You have another 2. So another 2, you can put in the middle. Usually put in the middle. Right? So this is 18. Okay. So these are the detailed steps, how you distribute the electron valence. You go to the middle, you give it the bonding pair. You start with the single bond first. Then you go to the lone pair, where is you give to the side of the member. Then once you distribute, then you look for the center again. So in this case, you check whether it's stable or not. So all the 18 electrons are given, but then you check whether it's stable or not. Sulfur, of course, you know it's not stable. It got 6 only. Then oxygen, stable. Oxygen, stable. So how to stable it? You need to build bonding. Means step number 4. How to build bonding? You need to pull electron from one side of the oxygen, right? Either pull from the left oxygen or right oxygen. Pull the 2 dot to the side, then it's stable already. Right? You pull this 2 dot to the side, oxygen stable, sulfur also stable, another side also stable. Okay. So we can form this one. So on the left side, if you count atom number 1 from the left, oxygen join double bond with second atoms and single bond with the third atoms. Right, so this is the first set of Levi's model that you can form. But when you do the arrangement later, just now, you can also discover that actually the atom number 3, which is a far right, also can share the electron. Right? So in this case, right? In this case, you can form double bond with the second atom with the third atoms. Now we're looking at the sequence of atoms. Before this example, we doesn't care sequence, but now we care about sequence. We count from the left. I count from the left. So atom number 1, atom number 2, atom number 3. So the first set does not same as second set. the character of the character of that compound is not same, the first one and the second one, because of the sequence. So these two are called resonance, means they are brothers, they are twin brothers. Okay. So in this case, you can write. So means I expected to see this set in your answer and this set in your answer. And then the last step you add, you need to give let me know how many Levi structures that that you can form. In this case, you need to tell. In this case, you have 2. So in your answer, you need to write there is 2 Levi structures for this SO2. I need to write how many you have. Then you represent your answer with this one, with double head arrow to represent resonance structures. Double head arrow. Okay, so with double head arrow, so the presentation will be like what you see on the screen here. So you put the first set molecule, and then the second set molecule on the right. Then in the middle, you need to write the double arrow. This represents resonance. Okay. Okay, so it means that in the real life, when you check under instrument, you can find 2 SO2 molecule, either on the left or on the right. So it can be switching between first one and second one. Okay. Okay, so this is the characteristic of what is resonance structures. Resonance structures, they have same skeletal structures. They have the same skeletal structures. However, the distribution of electron dot differ or different between them. Means the electron valence is different between them. This is the understanding that you need to have. Okay. And in the test or final exam is very direct. The question you will see, if the question asks you to draw Levi structures for resonance, means if you see resonance, if you see the question, if you see resonance, the keyword in the question means for sure you will have more than 1 Levi structures expected in the question. Yeah. Now, for example, the question will be added this line. Write the Levi structures for ion, included their resonance structures. Means this one is ask you to do the same steps, 4 steps. At the end, we want to see the double arrow as in your answer. Yeah. So this section is just add in the understanding of resonance structures, means more than 1 Levi structures. Then you add in the double arrow. For info, your test 1 or final exam, you will be seeing more than 2 Levi structures. So you need to think a little bit in the exam. What other combination that you have? Okay, so this one, just to show you, if you understand the concept, just to show you the step, build the skeletal structures. Second one, again, count the total number. And if you see ion, means it involves the extra steps. If it's negative charge, means you need to add electron in the total number. If it's positive charge, you need to remove electron from the equation. Yeah, so this one, add 1 electron because it's negative charge. Yeah. So this one, by very quick one, if you understand periodic table, nitrogen is number 6, group 6, oxygen is 6. So you have 24th electron. But this is negative charge, so you have 25 electron. Make sense? Right. So I will go very fast. Again, reminder to draw the Levi structures for individual element, just for your answer check. Okay, so the answer is 24. Again, remember to check is ion positive charge or negative charge. Then you distribute. In this case, you try to pair them together. So start with the bonding pair with the middle one. So since you have a skeletal structure of 3 neighbors, so you give 2 electron, 2 electron, 2 electron to each of the neighbor. So use 6. 24 minus 6, you got 18. Then divide the lone pair to the neighbor. Okay, something like this. Then you check whether stable or not. Oxygen confirm stable, 8, 8, 8, but nitrogen do not stable. One way, step number 4, to become stable is you build bonding, right? So how you build bonding? You share the 2 dot to the middle, either one, right? So because nitrogen only lack of 2 electron, so either one of the element can share 2 element to the middle. This form 3 different structures already. So when you see resonance question, you need to be sensitive to the location or identity of each element. You can label atom 1, atom 2, atom 3, atom 4, for example. Or in the middle, atom 1, and then you start counting clockwise. You can start from the middle top, item number 2, item number 3, item number 4. Just to do not confuse yourself. Then you donate the electron balance. So from here, you know that how many resonance structure you can form by just looking at this one. You can form another 2 different one, right? So one set is this one share here, one set is top share, one right share. So you have 3 answers. Okay. So how you do? So the final answer will be like this, right? So final answer will be like this. Remember, because this is charges, add the bracket with the negative sign or positive sign at the right of the bracket. Right, this, and then change the double dot into lines to see whether bonding, because this step is important when they go to the another chapter later or later section to predict the shape of the structures. Okay, any questions so far up to here? Can right. So you know that you can build another 2, something like this. So this one, double bond at the right hand side, you can also form at the top or at the left. Right? So how you write your answer, complete answer? Use the double arrow. This action is just to highlight the double arrow to represent resonance structure. Final answer, I'm looking for, if this is the question of the test, I'm looking for this answer. You need to write bracket, double arrow, bracket, double arrow, bracket, if this is ion. This is the test or final exam standard, this question. Yeah. So if no question, we move to the next one. This one I consider as your homework if you understand example just now. Right? Okay, this is okay, just now is NO3. This is NO2 negative. So at the end, you should able to see your answer with the bracket, negative, and then you try to see how many set of resonance you have. Okay, so this one I go very fast. You go home and check. If you don't understand, you can come to see me during consultation hour. Okay, just want to highlight during step number 2, this is negative charge. You need to add electron. Okay, then balance the equation. Step number 4, build bonding, and then you check how many sets you can form by labeling in your mind item number 1, item number 2, item number 3. Then you see how many sets you can form. Right? So this one have 2 sets. So remember to use the double arrow. Okay. Sometimes test question will ask you to prove. Proof means you need to write step 1, do what, step 2, do what, step 3, then at the end you arrive. Okay? All right. Now we go into predicting shape. Predicting shape. When it comes to this section, don't worry, in the test, you'll be given a table. You just need to know which one to refer, right? Periodic table. You'll be given one complete table to see, and then you need to know how to count the numbers, right? Okay. When you see the question, it asks you to use VSEPR theory. It means confirm sure it will fall under predicting the shape of the model. Okay. VSEPR is valence shell electron pair repulsion theory, but we won't go in deep into that. It's just that it is a set of theory to predict the behavior of chemical. Okay, but just for info, if the question in test 1, test 2, or final exam, if you see VSEPR theory, it means it asks you to use table to predict already. Okay. So what does this VSEPR theory do? It just tell you that if you have same charges, it repel each other. Positive, positive will repel each other. Negative, negative will repel each other. Positive, negative will attract each other. Okay. So the theory, VSEPR theory, it just means that if you have the lone pair, they will repel each other. Okay. Right. So the repulsion between the negative charge and electron groups of the central determine the geometry of the molecule. So that like the one that you see in your tutorial question there, right? So what does it mean? Lone pair, single bond, double bond. If you have, like for example, linear, you have double bond. You have single bond, two sides, means they are balanced, right? So if you have 3 pairs, it will distribute equally, become trigonal panel. This is just illustration, but you're given a table later. So 4 groups, if you have 4 groups with 0 lone pair, means it's a complete stable sharing electron. Means there's no lone pairs. So on the top one is without lone pairs. So you have 4 groups. 4 groups will be like a tower, your tripod, your camera tripod. Okay. In your test 2 or test 1, you're asked to draw the shape. Okay. And then you see, start from the third example here, you see there's a dash, 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 that one. It's actually to represent is at the back of the things. But later I'll show you. Okay. If it's 5 groups, then it divide 360 divided by 5. So you will like distribute equally the angle. 6 group also divided equally. This one is in 3D. 360, it divide equally the force. So if you have lone pair, if there's extra lone pair, for example, you have a band. Band means if you have linear like this, right? Linear 180, but you have a double dot lone pair, means they will push the arm down. It's called band. It will bend the bonds. Right? They look like this, and so on. Okay, so from here, if it double lone pair, it further push the leg, it further push the bond down. Right? Because electron and electron, they will push each other. Negative, negative, they will push each other. Right? And so on. If it's 3 lone pair, then it balances back. This one, you have to see it in the 3D form. It's not like 2D, you have to see it in the 3D form. Okay. All right. So consider CO2 again. Of course, in the question you won't, in the question for test 1 and exam, you won't see CO2 because you already discussed in the class. You won't see it. So CO2, if I give you this Levi structure, you should be able to know how to write this one already right now. Okay. So you need to prove this is just a homework lah. Prove this that CO2 have these Levi structures. All right. Now, because you know that it's a double bond and we have the lone pair. So you have 1 lone pair, 2 lone pair, 3 lone pair, 4 lone pair. But each side you have 2 lone pair. Right? So in this case, we look at the double bonds. You look at double bonds, you have linear. Means you will be balanced. Right? 180. Okay. H2CO2. This example is one of the tutorial questions. Asks you to draw the Levi structures. Right? It should look something like this. Let's see, double. So these 3 electron groups in the center. How you calculate electron groups? This one is referring to the center. Referring to the center atom, not the side. So here, center atom got 3 electron groups. Means 1, 2, 3. Double bond become count as one group. Triple bond also considered as one group. So you only count how many type of bond you have. How many bonds you have. Right? So here you have three electron groups. Okay. So you have something like this. It's called trigonal panels. Okay. Again, there is a table for you to refer in the test. I just want you to write the answer based on the table. The table will ask you to count how many electron groups, how many lone groups. Then you refer to table, you give me what is that. It's a long question in the exam. So CCH4 also same. So CCH4, the structure look like that. So there are 4 electron groups. You should be able to understand. If we mention 4 electron group, means you count how many bonds you have. 4 single bond. Okay. So again, it looks something like this in 3D. So this one again, tetrahedral, it means tripod shape. This one you can find in the table in exam. Okay. So what happens if there's a lone pair? I already give you in the diagram just now. Lone pair will push the band down. Will push the bonding down. Right? So the answer is it will repel the electron groups. Electron group is the bonding. A single bond, double bond, triple bond. It will push the bonding down. Okay. So consider this one, NH3 molecule. So you have a lone pair there. So if you have lone pair, then I think you can imagine this one will push the two bonding HH to the top. You push like that, right? So here, are you able to understand? Here you have 4 electron groups. You know, 1 lone pair, 1 lone pair, 1 lone pair, and one single bond, 1 single bond, 1 single bond, and 1 lone pair. Okay, so you have 4 electron groups. Okay, don't confuse with the electrons. If you only see electron, then another meaning. This is group. It asks you to count group. Yeah. So in the table later, if you count 4 electron groups, you will know this one is under tetrahedral. Tetrahedral is a tripod shape. Okay, and you need to add the 2-dot lone pair at the top if you draw three-dimensional structures. Yeah. All right. Okay, this question will come out in the final exam. Right. So this is just how you find. No complex thing here. Okay. So it's just to highlight, lone pair actually will influence the shape of the structures. Lone pair will push down the bonding, or it will affect the angle of the bonding. Right? How many angle doesn't matter in this module? All right, because we are not studying molecular science. But the shape, yes. You need to know how to refer to the table. Huh? Okay. So if we mention H2O, there are 4 electron groups. You're able to understand, right? Single bond, lone pair, single bond, lone pair. So you have 2 bonding, two single bond, 2 lone pair. Or total, you have 4 electron groups. Yeah. So this one, how you get this? This shape is referring to table based on the count of your electron groups. Okay, so this is called band. Band means it's push down the thing. Okay, so you can see there are 2 different words here. One is molecular geometry. Molecular geometry means you look at the overall shape. It's called band structure. Means you push down, the 2 dot will push down without the dot here. In the molecular geometry, we don't draw the dot. We don't draw the valence. We only look at the element. But if the electron geometry, we look at electron configuration. So here you will see lone pair. You will see lone pair, and then you give you the tetrahedral. This one also refer to table. In the table, you will see two column. One column is for electron geometry. One column is molecular geometry. So when you read the table, just be careful. The question sometimes asks you electron geometry, sometimes it asks you molecular geometry. So you need to read the correct column. Okay, right, something like this. So in your tutorial, I give you this one, right? Okay, so you count in the question, you count, you do the Levi structure, then you count how many electron groups, how many lone pair, double bond, how many single bond, double bond, triple bond, how many lone pair. Only these 4 category only. Then you count how many bonding groups. Bonding groups, bonding group refer to single bond, double bond, triple bond. Lone pair means that's those that without partners. Okay, linear means straight away your answer for 220 will be electron geometry, means you're looking at the electron effect, will be linear. The molecular geometry will be linear. So it will be electron geometry like this. Molecular geometry is this 3D dimension, a 3D projection, right? So same, same, only this one. This one a bit different. You see the electron geometry and the molecular geometry is different. So read carefully from the table. Depend on the question asks you. Either question asks you molecular geometry or electron geometry. You need to be careful. All right, so this one is just read from the table. The previous steps still the same by developing the Levi structure, the 4 steps, still the same. right? So predicting is very easy. You just refer to table, right? Just be careful. There are some notes in this table. For ammonia, I go and find out what is the equation of ammonia. Ammonia, the angle is 107 degree. Because here you got the angle between electron groups. So, for example, ammonia, the angle through calculation, you arrive at somewhere this angle. But read from this table, ammonia is 107, not 109 or 120. For ammonia, it's 107. And for water is 104.5 and not 180 degree. Not under this one, not under the band. The band 120, right? But water is 104.5. Just take note on this one. Okay. So this is when you go into experimental results, when you study degree later, maybe you're interested in chemical. So this table you see already, then just take note. There are some special note under the table. Okay, let's do exercise. Predict electron. It asks you to predict the electron and molecular geometry. There are two geometry here. It asks you to predict electron geometry and molecular geometry using VSEPR theory. When you see the question mentioning VSEPR theory related to the table already, confirm sure you need to use the table. The table will be in appendix, either below the question or at the back of the question. If you receive in the exam, final exam, you receive the exam paper and you flip, hey, don't have this table, you need to raise your hand. Sir, I don't have this table to predict the geometry. Okay. So PCl3, I will skip the Levi's development. I mean the calculation, all these things. The 4 step I will skip. I'll just straight away go to how you apply the table. So this one you should able to do already. Okay, PCl4 at the end. You are okay. PCl4. What is important is you count when you reach these steps, right? So just take this as the screen answer for your conclusion later. So by looking at these structures, right? PCl, you know that how many bonding you have, bonding groups, by looking at the one on the screen here. It forming what? Double bond or single bond? Single bond, how many single bond? 3 bonding groups. How many lone pair? So look at the center only, center. You're looking at the center of the molecule. 1 lone pair. Sorry, 2 lone pair. If you look at P, look at center. Okay, I mean this table. Okay, lone pairs. So you count, you refer to the table. Electron geometries. You have 4 electron groups. Who don't understand why 4 electron groups? Lone pair, and sorry, single bond, and lone pair. So you have 4 electron groups. So it's here. You go to the first column, go and find 4. There are 4 electron groups, right? You can refer to these two also possible. Then you need to go and find bonding groups. Okay, so we have 4 bonding groups. 4 bonding groups. Sorry, I think this is a wrong highlight. It's not 4. How many? 3. So this kind of answer you will see in the assignment question. I'll purposely give you the wrong one. You need to give me the correct one. So this one, bonding groups, you have 3 and 1 lone pairs. So I think the box I highlight on the screen here is wrong. It's incorrect. You should refer to the last 2 columns. Which is your electron geometry will be tetrahedral. Your molecular geometry will be trigonal pyramidal. These are the 2 keywords I'm looking for if this one come out in the exam. Yeah? Any question? No, Again, there are some error. The box is in the wrong place. Right? So be careful during the revision. Okay. All right. Now, another example, just go very quick. If you have question, just ask me. If you're asked to do NO3 negative using VSEPR theory, for sure you need to refer to the table already. Right? So let's say you already do all the things, you arrive at this answer. Okay. Based on, if you stop here, are you able to guess the molecular geometry, electron geometry? How many, How many electron groups? How many electron groups? This one, double dot form, single bond, double bond. How many? 3. Okay, got any lone pairs? No. So 3 electron groups, bonding groups. How many bonding groups? 3. So 3, 3. Lone pair 0 is the second column, right? In the table. Refer to table. So you have 3 electron groups. You're able to understand why it's 3. So the electron geometry will be trigonoplanar and the molecular geometry will be trigonoplanar also. There are 2 answers, 2 different answers. One is for electron geometry, one is for molecular geometry. Okay. All right. Okay. In my slides, the red one is sorry, I think I put in the wrong place already. One I think I tried to show the electron geometry, one I tried to show the molecular geometry. Okay. There's some error in my box location, yeah. Okay, so this one is your homework, these 2. Again, in the test or final exam, if you see a certain keyword, it means you refer to a certain section of the class, right? Okay. This one also check. Okay, so this one, just a quick quiz. Which condition necessary leads to the molecular geometry that is identical to electron geometry? This is just to check your understanding. Which condition necessary leads to molecular geometry that's identical to the electron geometry? Here I ask you, what is the difference between molecular and electron? What condition so that these 2 are the same? Look at the table. They actually ask you the understanding of table. Okay, if you look at this table, at what condition electron geometry was same as molecular geometry? You see the pattern? This one is the same. Look at the numbers. What are the similarity? Here and here is the same. Okay, you see the pattern, right? So this one also same. Look at the numbers. Do you see the pattern? Then this one is different. So what are the similarity? What's must same? These two must same, huh? Okay. So the answer for the small quiz here will be the same, but the lone pair is always 0. Okay, you cannot have lone pair. Once you have lone pair, then it will affect. It will try to push the pairs down or push the pair up. So lone pair they got effect on. Okay. We was just a little bit more. This is just your reading. Just your reading. If you see some papers or some textbook, they will use straight lines to represent bond. If you see the arrow with the hash line, this one is into the paper, means if I represent this marker pen, so it will go inside the paper like this. The bonding is go inside the paper. So this, because it's got hidden like hidden line you learn in your technical drawing, right? Hidden line. Then wedges is projecting out of the paper. If you see triangular, it means it go out. The leg is coming out from the paper. This one you read, you read. So these are some of the example. Okay. Right, so you have straight line, hash line, and wedge. Actually, you don't need to take photo. I'll give you the PowerPoint later in the island. Right. Okay. I think can we go very fast? 2 minutes more. This one is not inside your syllabus, but it will somehow it will somehow help you in the normal life question. Why oil and water doesn't mix? Maybe you stop here for a short break. Then I will go into this one. Okay, we come back maybe 110, 110. Okay, right. Mm.